Okay, so today we are going to discuss on the method of section. So we have here an example and we determine the force in members BD, CD, and CE of the roof truss. So we can actually solve for this using the method of joints. And so we have another method, and that is what we call as the method of sections. And in the method of sections, that is why this is called the method of sections, because we are going to make a section out of the structure that is given. So it is always good to start solving for the reactions when we are going to analyze a structure. So in this case, we solve first for the reaction at roller A and the reaction at pin F. So by that, we have a reaction, a vertical reaction of roller, and we assume only a vertical reaction at RF because there is no external force acting along the x-axis. And so solving for RF and RA, we take moment at A to solve for RF, and we take moment at F to solve for RA, and so we have RA is equals to 1,200 and RF is equals to 2,400. So validating that one, RF plus RA should be equal to 3,600, and 1, 2 plus 2, 4 is equals to 3,600, and we have a correct solution. So since it is a method of section, so we create a sectioning in members BD, CD, and CE. And that is what we are looking for, a force in the members BD, CD, and CE. So we can, instead of solving for the method of joints, having solved for the forces using the joint C or joint B or joint D, we can directly solve for these members by using the method of sections. So the next thing is we consider the left section. So if that would be the case, we cut the left section. So in cutting the left section, this will be our figure now. So remember that in doing the free body diagram, if we omit something, then we represent the omitted members as a force. And so we have our free body diagram here should be a reaction at A, and that is a compressive. We assume tensile for the forces of the member CE, and this is CD, a tensile, and again BD, a tensile. So this will be our free body diagram. So in here, we can solve for the summation of all forces along X should be equal to 0. Summation of forces along Y should be equal to 0. Or we can take moment with respect to any of these points, and that should be equal to 0. So if we solve for the summation of all forces along X, so what we'll have is CE, BD, and then we have the X component of CD. And so we have BD plus CE plus CD, 12 over 15. So this is 15. The hypotenuse is 15 here. So we have 12 because this is 12 and that is 15. So X component is cosine. So we have cosine theta is equals to adjacent over hypotenuse, and so we have a 12 over 15. And so we have BD is equals to, manipulating this one, you have a negative CE minus CD 4 over 5. So we just simplify 12 over 15 to 4 over 5. So summation of forces along Y is equal to 0, and so we have RA plus CD is equals to 9 over 15 equals to 0, and CD is equals to negative RA 5 over 3. And so we can have a value for CD, and that is equals to negative 2,000 pounds. And since CD here is a negative value and we assume a tensile, so that would mean that the CD is a compressive force. So we take moment at C. Why do we take moment at C? We can actually take moment at C so that we can immediately solve for the BD. So whichever comes first, that's okay. So we take moment at C, and that would be equal to 0. And so we have BD times moment arm is 9. And it's a positive, and this is also a positive. So that would mean that the other one is negative. So we have RA is equals to, IBD is equals to negative RA times 12 over 9. And so we have a negative value again, and so we assume that BD is tensile, and this, since we have solved for a negative value, then that would mean that BD is a compressive force. So what is CE? So from the equation previously, we can manipulate this and just solve for CE. C is equals to negative CD minus BD. So we have a negative CD minus BD, and we use the negative values of BD and CD since the free body diagram was unchanged. So since this is still our free body diagram and we have this as our working equation, then we still use the negative value. So C is equals to negative 1/6 and minus negative 2,000. So this is a negative, so that's a positive, and so we have our CE as 3,200 pounds. And since this is a positive value, our assumption in the free body diagram is a tensile force. CE is a tensile force, then that would mean that tensile force is correct. Okay, so how about the right section? So if we have used earlier previously the left section, this left section, the forces in the members BD, CD and CE should also be equal to what will be solved in the right section. Okay, so that would mean that whichever section you select, whether it's in the right section or the left section, still the answers of the forces acting on members BD and CD and CE should be the same. So let's take a look at solving using the right section. So if this is the right section, so we have 3,600 pounds, we have point B and point F, and the free body diagram here would be, this will be the reaction at pin F, this is 3,600. We assume again a tensile reaction at CE. So, and this is also a tensile reaction at CD, and we also have a tensile reaction at BD. So referring to this free body diagram, we can take moment at D. So this is our D, we take moment at D, and we can immediately solve for CE here. And so our CE is taking moment at D is equals to 0. We have CE times its moment arm is 9. That's A clockwise. And that would be equal to the counterclockwise moment effect of RF times its moment arm is 12. So 3,600 have no moment arm because it's coinciding to, it's passing through point D. Okay. So we have C is equals to RF 12 over 9, and so we have RF, as we have solved earlier, is 2,400, and that's multiplied by 12 over 9, so we have CE is equals to 3,200 pounds. And since this is a positive, then CE is tensile. And this is actually the same to what we have solved earlier in the left section. So let's see CE in the left section. Okay, so there we have. And the next is we take the summation of all forces along y. So what are the forces involved? We have 3,600 RF and we have CD sine theta. So we assume theta here, we state theta here, and so we have CD sine theta plus 3,600 should be equal to RF. And CD is equals to, manipulating that one, manipulating this, we have 2,400 RF minus 3,600 all over sine theta. And so we have a negative 1,200 over sine theta is opposite over adjacent. So this is our theta here. And we have opposite side is 9 all over this side is 15. And so we have CD, answer for CD is negative 2,000 pounds. And since we have a negative value, then our assumption is a tensile force at CD. So that would mean that the direction of CD is not a tensile force, but rather it's a compressive force. And this is actually the same with what we have solved earlier. So let's see CD. So we have a compressive force of 2,000. So the next force that we are going to solve is what? So we have CE, CD, and we can solve for BD. So what is BD? So we can just take the summation of all forces along x-axis, and we have a negative BD minus CD minus CE is equal to 0. And so we can solve for BD is equal to negative CD cosine theta minus CE, and CD as we solved is negative 2,000 times 12 over 15. So this is cosine theta minus 3,200. So we have the value for BD is equal to 2,000 4 over 5 minus 3,200, and so we have a negative 1,600 pounds. So since this is a negative, we assume BD here as tensile, and that would mean that BD is compressive. So let's see if what we have solved earlier for BD is, yes, so they are the same, 1,600 compressive force. And so that's all for the method of sections.